formulation, oxides, and hydrides. I think I can do a presentation only about oxides. Okay, good. As we know, this are the prefix we're going to use. We normally don't use mono, and these prefixes are help to know how many elements do we have in the compound, in each compound. This is an example, magnesium oxide, not magnesium oxygen. Okay, the oxides, we're going to change the end of the word. Instead of I-gen, we use ide. Okay, these two examples. Good. Lithium has only one oxidation number, +1, oxygen -2. Okay, so we shift the oxidation number of oxygen and we put it close to the lithium. Okay, and then we call it the lithium. Okay, because it means that we have 2 lithiums and 1 oxygen. Okay, to balance the compound. So we are going to have 2 lithiums, okay, and 1 oxygen. Okay, so why we put 2? Because lithium has oxidation number +1 and +1, and the oxidation number of oxygen is -2. So +1 and +1 is 2. 2 minus 2 is equals 0. Okay, this is the way that the molecules are stable. They are looking for being with another element to find their valence. The valence is when you sum all the oxidation numbers equals 0. That's when a compound is stable. Okay, so the trick to shift the oxidation numbers, we will have here 1. Okay, from lithium. We don't write the signs of each oxidation number. So this is just a trick to know how many lithiums do I need to balance the -2 oxidation number of oxygen. So we need 2 lithiums. Okay. Okay. Explanation. We use the prefix D to describe that there are 2 lithiums. In the case of the stock nomenclature, we don't use oxidation number, we don't use Roman name numbers, because lithium has only 1 oxidation number, which is mass +1, and the oxidation number of oxygen is -2. They only have 1, so we don't need to write it down. Okay, this is the most difficult name, because we need to remember that lithium has oxidation number +1 and oxygen -2. So to write the correct compound, we need to remember that the lithium has +1 and the oxide -2. Okay, it's here. Good. Next example, barium. This is in the second column of the periodic table, and oxygen -2. So they have swift the oxidation numbers to put here in the bottom part of the element. Okay, so what we do here is divide it by 2. Okay, very good. This is not a very nice 2, but computer is not working properly. It looks like an 8. Damn. Um, good. Anyway, when we divide it by 2, we have the final result of this BaO, barium oxide. We avoid the use of prefix mono. Is this exactly the same as the stock barium oxide? And as we did in the previous example, when two elements have only one oxidation number, we don't need to use the um, the Roman numbers. Okay, good. Next examples. D copper. Okay, D copper oxide, because we shift oxidation numbers to balance the compound. So we put 2 coppers that have +1 as an oxidation number, and therefore we're going to have D to describe that there are 2 coppers. Okay, 2 coppers and 1 oxygen. We don't need to use mono, as we said. The stock nomenclature in this case, because copper has more than 1 oxidation number, we need to let know the scientist that the copper in this case, in this compound, has an oxidation number of +1, that we mark it here. So therefore, the scientist is going to know that, okay, if oxygen has -2 and copper has +1, therefore my compound will look like this. Okay? Because these 2 means that we have to have two coppers. 2. Okay? Because coppers have 1 oxidation number. Okay? +1 multiply by 2 . Okay. Yes. So 2 coppers with +1 multiply by 2. Therefore, we'll have +2. And the oxygen, we only have 1. That is -2. Therefore, is equal 0. This molecule is balanced. Okay, in this case, carbon dioxide. This is very tricky because in this case, carbon has 4 oxidation number, and we shift. Okay, we put it close to oxygen, and oxygen, of course, again is -2. We put it close to carbon, and we divide this component by 2. Okay, by 2. Therefore, 2 between 2 is 1. We don't write it. 4 between 2 is 2. We write it. Okay, so we have carbon dioxide. Carbon dioxide. This is very simple in English because in Spanish it's the other way around. We will say dióxido de carbono. But in this case in English, like you, we read it from left to right, and we write it also like that. Okay? We use prefix D to describe what we have two oxygens in this molecule, okay? And in this case, because carbon has more than one oxidation number, in this case is we need to write 4, okay? 4 in the in Roman numbers, okay? To mark it that we are using the oxidation number of carbon plus 4. What will happen if the carbon has oxidation number 2 and oxygen again will have the same oxidation number -2? We shift oxidation numbers, we write it close to each element, and we divide both of them between 2, okay? So therefore, I don't know why it's not writing, but anyway. Now you're writing, okay, we divided 2 by 2 and 2 by 2, so we will have carbon monoxide. This is one of the few examples that we write mono, okay? This is an exception, carbon monoxide. How we call this molecule in the stock nomenclature, we use this oxidation number of carbon here. We write it plus 2 or 2 in the Roman numbers to let the scientist know that the carbon, in this case, when mixed with this oxygen, has oxidation number plus 2. Okay, so the scientist will know that the compound will look like this. And in this case, the scientist will know, oh, carbon 4. Okay, so a carbon and then an oxygen, so CO2. My God, it's difficult, you know that. Clever people. Let's see the next slide. Good. We went through this. Now, okay, in this case, we're going to use iron 2. So, sorry. So, okay. Oxygen is always the same. We shift. We put it in both sides of the compound. We divide it by 2. Iron oxide. We don't use prefix mono in this case. Iron in stock nomenclature has this blah 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 Roman number. Okay, because iron has more than 2 oxidation number. Good. We write 2 to describe that iron has oxidation number plus 2. We don't write the oxidation number of oxygen because it always has -2. What will happen if we mixed the iron and oxygen when iron has +3 as oxidation number? We shift, we put the 3 close to oxygen, and we put the 2 of oxygen, of oxidation number of oxygen, close to iron. Okay? So, the iron oxide, okay? Which means that D has 2 and 3 has 3, of course. Okay? The iron trioxide. Sorry, I don't remember if I say it properly the first time. Okay, the iron trioxide And in stock nomenclature, if we know that iron has 3 and oxygen, of course, has -2, the scientist will know, okay, this is my iron, this is my oxygen. So we swift 3, we put it here, and the oxidation number of oxygen is 2. Okay, so we get it. It's very easy. Potassium. Potassium has only one oxidation number. Hidrógeno, litio, sodio, potasio, rubidio, cesio, francio. First column, oxygen again, -2. We swift oxidation numbers. We put the oxidation number of oxygen close to potassium. And the name is D-potassium oxide. Very easy. We use prefix D to describe that there are 2 potassium. Potassium oxide. As I said, potassium has only one oxidation number, so we don't need to use the Roman number. Okay, the scientists will know, okay, potassium +1, oxygen -2, so I write this. Okay, good. Next, the apple. Okay, good. Manganese. Manganese +6. Okay, manganese has more than one oxidation number. We swift again oxidation numbers and then divide it by 2. Okay, 2 between 2 is 1, we don't write it. 6 between 2 is 3. So how we call it in systematic? Manganese trioxide, as we can see here, 3 oxygen. In stock nomenclature, manganese 6 oxide. Okay, we write 6 to describe manganese, has oxidation number +6. Okay, and the scientists will know, oxide, okay, manganese 6, oxygen -2, we swift and then divided by 3. Okay, good. Nitrogen. Again, nitrogen has more than 2 oxidation numbers, more than 1, sorry. In this case has +3. We swift oxidation numbers and stays like that. D nitrogen 3 oxide, D because we have 2 nitrogen, 3 because we have 3 oxygens. Okay, nitrogen 3, we use this oxidation number. We need to write it because the scientists need to know, okay, nitrogen 3, okay, oxygen 2, so we swift the oxidation numbers, and as a result we have this compound. Okay, zinc. It's good to zinc sometimes. Okay, zinc has 2 oxidation number and oxygen has 2 oxidation number. As you know, we write it down, we swift and then divide it by what? 2. Very good. 2, we divide it by 2, and then we have this compound simplified, zinc oxide. We don't use the prefix mono. In the case of the stock nomenclature, we don't write 2 Roman number because zinc has only one oxidation number, which is +2. We don't write the oxidation number of oxygen because it always have -2. Okay, and I think I'm going to stop here, and the next video will be about